Okay, here are a couple problems from 3.5. Problem number 4. We're told that y is equal to x secant x, and we're asked to find what is dy dx. I want to remind you that we should be comfortable with the scenario of writing out explicitly our starting point, the actions that we follow, and very clearly getting to the ending point that answers the question that's being asked, right? So if I want to get dy dx, I am going to take the derivative of y with respect to x. Of course, whatever I do to one side of the equation, I need to do to the other. All right? Now over here, we know the result of that derivative is dy dx. On the other side, we see a product rule. So even though the focus of this particular section was about the trigonometric derivatives, we're still saying that this is two functions of x being multiplied by each other. So we think of it as first times the derivative of the second plus the second times the derivative of the first. Yes?
Would x be considered a constant?
No, x is a variable.
Would it be considered a constant multiplier?
No, it is a variable. Okay, constants are things that always have the same value, always. Okay, x can have varying values, so it is a variable. So the derivative of secant, as we found out before, is secant tangent, and you should have memorized this by now. If you are a note card, flashcard person, this would be something that you would probably want to have on your flashcard. On one side of your flashcard, the derivative with respect to x of secant x, and on the other side of the flashcard, secant x tangent x. All right. Plus secant times, what is the derivative of x? 1. So there we have it. X, secant x, tangent x, plus secant x. Done.
Yeah, we just.
Number 10. In number 10, we have y is equal to cosine x over 1 plus sine x. Again, I'm looking for dy dx, so I'm going to take the derivative with respect to x of both sides. Cosine of x over 1 plus sine of x. This time, what rule is hopping out at us? The quotient rule. All right. So let's do the mantra for the quotient rule. That dy dx is equal to the bottom times the derivative of the top minus the top times the derivative of the bottom all over d, the bottom squared. Okay, let's go ahead. The derivative of cosine is negative sine. The derivative of 1 plus sine is cosine. And if we start to clean this up, I distribute this through, I'm going to get sine times 1 is sine of x. Negative sine of x. Negative sine times positive sine is negative sine squared of x minus cosine squared of x, and this is all over 1 plus sine of x quantity squared. This thing here looks familiar. If I factor out a negative sign out of those two terms, I get sine squared x plus cosine squared x. Now, my students from Lanphier, whenever they see that, they all yell out, and I don't know why, Big Mama. And there we have it.
All right, big mama.
So there's number 10. Do you know, have we covered all 6 of the derivatives of trig?
We missed the last two.
We missed the last 2? Okay.
We had to look at the book for them.
All right. Let me close this recording off. Ian, is this a homework question?
Yeah.
Okay, then I'll keep rolling. Go ahead.
What? How did you get the negative sin x? How did you factor that out? Or how did you
Well,
get?
I see sine x plus 1
No, the step before that.
here.
Yeah. How did you get from that to that?
Well, I see a negative 1 and I see a negative 1 here and there. So I factored the negative 1 out.
Oh, I thought you said you factored in negative sin x out.
No, I factored the negative 1 out and then it left me with the Pythagorean identity.
Okay.
All right. Are we now done with this?
Yeah.
Okay, so let me turn off the recording for this.